Okay, so what we're going to do is we are going to find the amount of moles in a sample given mass. Now, normally when you do this, you start with atoms and then we build up. So we're going to do a quick example with atoms and then build to molecules. So let's look at, as an example, oops, I don't need red. Let's look at 50 grams of sodium. And the way we would convert that is on the periodic table, we would find sodium, which is on the left side, and it has an atomic number of 11 and an atomic mass of roughly 22.99. And so we're going to use that 22.99 for our benefit. So we're going to set it up as 50 grams of Na. Notice I'm labeling times. And now here's the part that you want to be kind of cognizant of. Because I have grams here, I'm going to put grams on the bottom. And because I'm trying to get to moles, I'm going to put moles on top. And now we're going to use our 22.99, and I'm going to rewrite this as 22.99 grams in every 1 mole of Na. Notice I'm using it directly from the periodic table. And I'm just going to take that and I'm going to plug it in. So 22.99 is attached to the grams, so I'm going to put it by the grams. And the 1 mole is going to go with the moles, so I'm going to put Na after it. And then I am just going to plug that in. If you need it visually, it's going to look like 50 over 22.99. And then you can plug that into your calculator. I'm going to do the same. And I am getting 2.17 moles of Na. So that would be what we would do if we had just it in its atomic state. However, sodium really isn't found in its atomic state. It's pretty reactive. So really, let's see what happens if we had 100 grams of sodium oxide. That's a 2. And so the question is how many moles of Na? So we are going to do the following. We're still going to use the periodic table. We already have Na from the prior problem, so I'm not going to rewrite it. But we do need oxygen because oxygen is in this problem. Oxygen has an atomic number of 8 and an atomic mass of 15.99. And we're going to rewrite that 15.99 in the same way we did before. So we're going to do 15.99 grams over 1 mole of oxygen. And so we're going to set this up. So first thing, Na2O is made up of 2 NAs and 1 oxygen. So I'm going to do 2 times the atomic mass of sodium, which is 22.99, and 1 oxygen, which is 15.99. And then you can plug this into your calculator, and that is going to get us 61.97. And this value is going to be the grams of Na2O for every 1 mole of Na2O because we got this value from the periodic table. Now we're just going to set this up. We have 100 grams of Na2O times, and we're going to do the same thing. Remember, we have grams, so I'm going to put grams on the bottom to cancel. I'm going to put moles on the top, and I'm going to use my values and plug them in. So next to my grams, I have 61.97, and next to my moles, I have 1 and Na2O. And then from here, you can either solve this and then do the next part in the next step, or we're going to combine them. So the question asks us to find moles of Na. And right now I have found moles of Na2O, which isn't the same thing. So because I want to get to moles of Na, I'm going to put moles of Na on top and moles of Na2O on the bottom. Now, if we go back to when we were solving for the molar mass of Na2O, there were 2 NAs in there for every 1 molecule or 1 salt of Na2O. So we're going to do the same thing. So there's 2 NAs for every 1 mole of Na2O, and then you're just going to solve this all together, and that is going to give you your value for Na moles. So go ahead and plug that in. 100 divided by 61.97, and then multiplied by 2. So you should get 3.23 rounded moles of Na. If you get a different value, double check that your calculator isn't doing something funny with its order of operations, and then reset. And that's how you're going to do that.